Hey everyone, this is an example to balance redox reactions, and I think we're going to stick with it being in a acidic solution. So at the end you better have H pluses in your reaction and not OH minuses. So the process, especially if you're given an entire reaction kind of like this, where you have to split it yourself into half reactions, you're essentially going to want to find like species on one side, on the reaction side and the product side. So I'm seeing that an SO3 2 minus is essentially going to SO4 2 minus. And then also I'm going to split this page in half. That is 1/2 reaction on the left, and then the other half reaction we have MnO4 minus going to Mn, that's not an N, Mn2 plus. Okay, that's first step, is splitting up into your half reactions if it wasn't already given to you. Now the next step is balancing all atoms that are not oxygen and hydrogen. So on the left hand side I see one sulfur here, one sulfur here, so we're done with that step essentially. The next step is you figure out how many oxygens there are on each side. So I have 4 on the right, I have 3 on the left, and you need to essentially add oxygen to the system in by way of adding water to balance the oxygens only. So I'm noticing there's 3 on the left, so I need to add 1 more water on the left. Okay, because I'm essentially adding an oxygen. So total oxygens on the left are 4, total oxygens on the right are 4. But what I've done is I've added 2 hydrogens with that water, and how I counteract that, or balance that literally, is by adding 2 hydrogens in the form of H pluses to the right hand side, because we're trying to keep everything balanced. So to recap, we balanced atoms that were not oxygen or hydrogen. Then we balanced the oxygens by adding water. And then we balanced the hydrogens that were added to the system by adding H pluses. Good. Now everything is balanced here except the charge. So at this point you need to look at the charges on the left, and this entire system adds up to -2. Okay. And this system on the right, well, the SO4 2 minus is 2 minus, and you're adding 2 pluses essentially charge from those hydrogens, so this whole thing is actually 0. So what we do to balance this entire system out is we are going to add 2 electrons to the right, because now the right hand side has a -2 charge, the left hand side has a -2 charge. Good. So we're done with that for now. And we want to move over to the right hand side with this manganese species, and let's go and start all over again. So manganese on the left, there's only 1. Manganese on the right, there's only 1. Cool, we can move on. Now we need to go to oxygens. There are 4 on the left, there are none on the right. So what do we add to the right to give us more oxygens? We add 4 waters. Okay, so at this point we have we've added enough oxygens to balance out the system, but we've added hydrogens. We've added 8, in fact, 4 times 2. So if we've added 8, then we need to add 8 onto the left hand side to balance that out in terms of protons. Good. So at this point we need to look at charge again, because everything else is balanced. On the left hand side we have an 8 plus minus a 1, so we have a +7 on the left, and on the right hand side it looks to me like we have a +2 just from this. So we are going to add electrons, because that's the only thing you can add at this point. We need to add enough electrons to the system to balance. If you have a +7 on the left and a +2 on the right, you're adding negatives, so you're going to be adding 5 to the left to get the entire charge to come down to +2 to match the right hand side. Good. Now these half reactions seem to be balanced so far. And you can also figure out who is being essentially reduced or oxidized based on any mnemonic that you might remember. I was always taught oil rig. Oxidation is losing electrons. Reduction is gaining electrons. So I'm noticing that this reaction is gaining the electron, and this reaction is losing the electron. So this is the oxidation half reaction, and this is the reduction half reaction. Okay. Now we're almost getting there, but there's a bit more legwork we have to do because we need to combine these back together, these two reactions. You'll notice that the electrons do not balance out between the two. So you have to make them match. And the lowest number that you can essentially inflate this to is 10 electrons. And what you do is we're literally talking about multiplying the entire left-hand side by 5 and the entire right-hand side by 2 to get electrons to equal 10. So we have our final outcome, almost, kind of. We have essentially a 5 SO3 2 minus plus 5 water gives us 5 SO4 2 minus plus 10 protons plus 10 electrons. Cool. Now we do the right hand side. We get 16 protons plus 2 MnO4 minus plus 10 electrons gives us 2 Mn2 plus 8 water. Good. Now at this point we are very close to being done. We do have to combine these reactions together, and what that literally means is adding up the two left-hand sides together and adding up the two right-hand sides together. Okay, so let's write our final reaction now. So we have the left-hand side. Let me actually erase part of that. We have the left-hand side, which is your 5 SO3 2 minus plus 5 water plus 16 protons, because I'm jumping over to the right hand side, plus 2 MnO4 minus plus 10 electrons gives us, now I jump back over to this area right here because it's the right hand side, 5 SO4 2 minus plus 10 protons plus 10 electrons plus 2 Mn2 pluses, oh, I almost made it, and 8 waters. Long reaction. Now at this point we are very close to being done. We just need to cancel out a few things because we don't need them. So if you see, kind of just like mathematical equation, if you see an x on the left hand side and an x on the right hand side, you can subtract them. We can do the same thing here. 10 electrons on the left, 10 electrons on the right. We can get rid of them completely. With the protons, there are 10 here. There are 16. So this 16 reduces down to 6 because we're getting rid of 10. Similarly with water. This entire 5 water goes down to 0, and this reduces down to 3 because we're just subtracting it. And essentially we finally have our final equation, 5 SO3 2 minus aqueous plus 6 protons plus 2 MnO4 minus aqueous gives us 5 SO4 2 minus aqueous plus 2 Mn2 plus aqueous. Well, that's barely a Q. There we go. Plus 3 waters. That's liquid. Try my aqueous over here. Cool. So there is a full balancing a redox reaction. Practice these. These are, you know, pretty tedious, but once you get the hang of it, as far as the, you know, what you do first and the rules, because there's a sequence to the events, then it gets much easier over time, but it does take a lot of practice. So hopefully you find this helpful, and definitely keep practicing these.